How do you get the most electricity from a single lemon? Come up with a hypothesis and an explanation. Let us test our hypothesis. We will need a voltmeter, galvanized nails, pieces of copper wire, a lemon, soldering bits, a knife, some tissues, an A4 paper, and a marker. Roll the lemon on the table to become juicy without breaking the skin. For the control, insert a piece of copper wire and a nail deep into the lemon. The wire and the nail should be at least 3 centimeters away from each other. Turn on the voltmeter. Connect the red lead to the copper wire and connect the black lead to the nail. Switch their position if the readings are in negative. Write down the voltage displayed on the voltmeter. For the experiment, cut the lemon into 4 pieces. Insert a piece of copper wire and a nail into each quarter at least 3 centimeters away from each other. Connect the soldering bit from one copper wire stuck in one piece of lemon to the nail stuck in the next piece of lemon. Repeat these connections until all the copper wires and the nails are connected except the first nail and the last copper wire. Turn on the voltmeter. Connect the red lead to the free copper wire and connect the black lead to the free nail. Switch their position if the readings are in negative. Write down the voltage displayed on the voltmeter. It can be noticed that the figure recorded when the lemon was cut is higher than when it was a whole. The wire, which is copper, and the galvanized nail, made of zinc, act as electrodes. Electrodes produce electrons and are therefore good conductors of electricity. The lemon juice is acidic in nature and it works as a powerful electrolyte, which means the juice serves as a reservoir for the transfer of electrons from the nail to the copper wire. The rate of flow of electrons between the 2 electrodes is measured using the voltmeter. Cutting the lemon fruit into smaller pieces increases the total amount of electron flow. This is as a result of the addition of individual voltages flow from each piece. Try extensions by comparing voltages of fruits such as tomato banana, and orange.